Today, we are going to uh, study about the algorithms. So, the basic data structures which are holding or storing elements or data we already cover. So, next time we are going to talk this time about the algorithms, how we are build algorithm. So first, let's understand what do you mean by algorithm. Algorithms is the step-by-steps procedure which solve my particular specific problem, specific situation, specific use case. So algorithm is nothing, just a solution for a specific problem, uh, and those problems we can uh, define with the step by steps, okay? So that our systems our program can perform this step number one, step number two, step number three, step number four, and after that say, hey, our particular use case or particular problems are addressed. The algorithm is the approach through which we can provide a solution, provide a uh, implementation of a particular problem, particular use case, particular task. So today, I taken a very simple problem like sorting. Okay. So let us. We have a list of elements. We have a list of elements, and that element have a come some number like 5, 2, 6, 7. So notice these elements are in a not a particular order, maybe ascending order, descending order. So sorting means putting element maybe ascending order or descending order. Ascending order may be smallest number, first one, then two, then three, then four, then five. This is the ascending order. Descending order maybe biggest element is the first, let's say 5, 4, 3, 2, and 1. So this is the ascending order. This is the descending order. That means कि whatever the elements we have, that are in a sorted order. So someone say, hey, I have a list of employee, list of data. Now I want to arrange the data in a particular order, maybe ascending or descending. So for those, we have to perform some specific steps. Step number one, step number two, step number three, step number four, and in this way we can solve. So for sorting in the algorithm, in the computer science, in the data structure, couple of the way to arrange in the ascending or descending order this list have a multiple way. So couple of way we are going to talk, maybe one or two, so that you can know how we can solve the problem. So one approach is the bubble sort. The bubble sort is the approach or algorithm that help us to arrange our list of elements in a particular order, maybe ascending or descending. So similarly, some different algorithm also available. Selection sort, insertion sort, quick sort, merge sort, ready sort. So for sorting the elements, we have a dozens of algorithms. So we are not going to cover each and every algorithm here, but our main purpose to know how we can write algorithms in the Python code so that we feel comfortable. If you have some requirement, we can write the step-wise step procedure to address the customer use case. Okay, this is general use case like ascending order, descending order. Like we have a list of employee. I want to make the employee name in a particular order, alphabetic order, or the age, or the department, or the salary. So many places we have it. bunch of data and I want to view, I want to display in a particular order. So for those, we have to know how to write our algorithm. So today we are going to talk the one of the algorithm, very simplest algorithm in the sorting is the bubble sort. So we can start from a simple so that we can understand the our intention is that we can understand how we can build the algorithm. So for building algorithm, we have to cover two things. One thing, what the approach to arrange my data in ascending order. One is the approach, one is the thinking, one is the logic. Second thing, how we can write those steps in the Python language. Okay. The two things we have to discuss. One, what are the logics or approach to address this sorting problem? And second, how we write, implement those logics or approach in a Python language. So let's talk the bubble sort. So bubble sort is the comparison based sorting algorithm. So here, what do mean with comparison? That means here, let's say we have a two number 7 and 6. Okay. So if we have a two number, I can compare which is the less than or which is the greater than. So here say 7 is the greater than 6. So this is the comparison based sorting. In this sorting, we are good to compare two elements and decided which is greater element or which is the less element. Okay, so bubble sort is a comparison based sorting algorithm that repeatedly step through the list. So whatever the we have a list of item, let's say we have a list of item and number of item maybe 2, 7, 1, 5. Okay, so these comparisons are going to you can say compare first two, then next two, then next two. First things, this is the comparison operator greater than or less than. Okay, these two operator we are used to make comparisons. So less than, greater than, and third operator equal to. So in this Pythons we have a double equal to. This is not equal to operator. So these are operator we can use to the compare elements. So whenever you are comparing elements, that this is the one operator, comparison operator, they have a required left side value and required right side value. So we need a two value to compare. This is the less than or greater than. And first thing, remember, comparison always happen with the same types of element. If here is the integer value, here should be integer. Here float, here float. Here character, here character. So generally, always to going to make the comparison, we require to one operator, maybe less than, maybe greater than, maybe equal to, right? And these operator is the binary operator. That means they require the two value, value 1 and value 2, so that you can make the comparison. Okay. So here, what this algorithm say? Algorithm say compare adjacent elements. So what this algorithm say, whatever the list we have, let's say we have a list of elements, list of element 3, 3, 5, 1. Okay. So you have to compare the adjacent element. That you have to compare this two element first, and if they are in the wrong order, means which you let's you are the ascending order. That means ki first element should be less than and second element should be greater than. If less than, if this condition is satisfied, the first element is less than the second element, that means they are in a proper order. If what happen, the first element is not less than, is a greater than, not less than. If not less than, that means this is a wrong order. If they are a wrong order, then we have to swap them. Swap them means ki whatever the letters are, you are this is the two element. Okay, this is the two element. Let's this is the five and this is the two. Okay, and you compare five is less than two. What do you think? Five is less than two? Answer is no. That means this the number in the wrong order. So what we have to do? We have to swap the number. Means you can say, hey, change the position. Whatever the place of 2, change here, and whatever the place of here, change here. So this is the swapping. Now here become a 2 and here become a 5. So this is the way we can swap element between the two places. So this is the basic fundamental. So we have two things. Compare adjacent elements. Means we compare first these two and then these two, then these two. Why? Because this is the repeated comparison. Similarly, you have to first do, then next do, then next do, and then next do. So we have to repeat this comparison, and if anything you found wrong, that you have to swap them. This process repeated until the list is solved. The same activity we have to do one time, two time, three time, four times. Okay. This is the way we can perform. We can say whatever the input list is a sorted list. So what is this? This is the approach. This is the problem. Bubble sorting is the one problem, and we have to provide one approach where we are going to compare every two adjacent element first with this, and then this, then this, then this, then this. Any order mismatch, we have to swap them. This activity, these things we have to do multiple time until the complete list is not sorted. Okay, so this is known as a bubble sort algorithm, a bubble sort approach. So let's understand the key concept here. First things, adjacent comparison means compare each pair of elements as we discussed. Okay, so this is the first things in the bubble sort. We have to compare each element with the adjacent. Compare this, compare this, compare this. Swapping. Swap if they are in wrong order. Sometime we have to swap the value of the, let's say this is 7 and this is a 6. So we have to require the swapping. We have to put 7 here and again put the 6 here. And passes, when I repeat the process for the all element. So here say, let's we have a 5 element. The first time we compare every element, this is a pass one. If still list is not sorted, you can compare again the same thing. Second pass, again compare the sum. The same activity you are doing to multiple time. And maybe here you can perform some kind of optimization. If no swap are made in the past, this is already sorted. The first time you say, hey, you comparing each element, each element, each element, and you found no swapping happen, that means this list is already sorted. So don't go do again next pass, next pass, next pass. So we have to make some optimization as well as. So three thing, major point, comparing adjacent elements, swapping if required, and passes means skip the complete pass 1, 2, 3 if there is no swapping happen in any pass. So let's understand with a simple example, step by steps with example. So let us we have element 3, 5, 3, 8, 2, 4 using the bubbles, right? The pass one means let's first time I am going to comparing each element with the adjacent. The first we have a 5 and 3. So we have to compare 5 and 3. 5 and 3. 5 is less than 3 because we are going to do ascending order. Less than 3? No. That means we require to swap these numbers. So we have to swap 3 and 5. Okay. And after that, notice compare 5 and 8. no swapping required. First you compare these two, swapping required. First compare these two. 5 less than 8, yes, true, no problem. Again, 8 less than 4, no, no, no. Again, here you have to require the swapping. Again, you swap the number here, 8 to 4. Okay, here set. So again, you say comparing 8 to 2. It's swapping required? Yes. Then we have to swap it. So whenever you have complete all the element comparison with the one time, this is known as a pass one. Notice in one pass, what you did, all the elements are not sorted, but the biggest element go at the last. Okay, so in one pass, you find the biggest element at the last. Okay, go to the second pass. Second pass, again compare here, again compare, no swapping. Again compare 5 and 4, again compare 5 and 4. Yes, swiping required. Then we have to again swipe here 4 and 5. Again compare 5 and 2. Yes. 5 less than 2. No. Again swiping required. Again you swipe the number. Again compare 5 and 8. No swiping required. So notice whenever pass second completed, you notice the 8 is the biggest and next time it is the 5 is the biggest. In the two pass, two biggest element go at the right place. Similarly, let's go to the past 3. Again, you compare 3 and 4. 3 less than 4, no swapping required. Again, compare 2 and 4. Again, 2 and 4. 4 and 2. 4 and 2 here. 4 and 2, swapping required. Again, you swap them. Again, compare 5 and 2. So, notice now this is the biggest one, pass 1. This is the biggest 2, pass 2. This is the biggest, pass 3. So, in this way, you can say our three elements find the proper place. Okay, let's pass 4. Compare first two elements. Compare 2 and 3. Yes, just swap them. And after that, no swapping required. So once this come, you notice all the elements are the sorted. So this is the approach where what you did, you have to compare every element to each other, every element to each other, every element compare this, and one pass you find this is the sort biggest element come to the last. Again go to the second pass again comparing first, second, third, and in this case you find the last two place is the biggest element. Again third pass you can compare and find the third is the best place you can find the biggest number. And again comparing and finally find the all the element at the right place. So this is known as pass 1, pass 2, pass 3, pass 4, pass 5 in this way. And every pass, at least the biggest number go to the first pass 1, second pass 2, third pass 3, fourth pass 4 in this way. So this is the your algorithm. This is the approach, the way you can apply sort. So we have to, whenever you are work on any algorithm, we have to do the two things. One, you have to define your approach, how you are going to solve the problem. Second, we have to go write the same steps in the code. So let's go and understand the coding part, how we can write this code. Okay, so here already. Okay. So this is the way we can do here. So whatever the code here written, whatever the approach we discuss, same thing here written. That means we have write one method bubble sort and receive one input array. Okay, so you have to receive your input array, and after we have to going to loop comparing one to these two, these two, these two, these two, these two, these two, these two. So we have to compare till the length. We have to calculate here this is my length. We have to run the loop from 0. This is the 0 position, 1 position, 2 position, 3 position, 4 position, 5 position. What are the position here? And just checking the optimization again. we have to one here start and again start from the 0 to again. So again stop the loop till -1. This first loop start from till last, second loop start till -1. And in this way, if you say anything is not in order, if not satisfy the my criteria, then we have to what say? We have to swap them, and this is the logic done. We have to repeat this. So due to that, we have to repeat this. We have to repeat. This is the pass one. This is the pass one. But one time, only one element started. So similarly, we have to do pass two, pass three. This is the law loop for your pass 2. So this is the first pass, and this pass similar work I want to repeat multiple times. So we have to written this code to swapping element. Okay, and this is do repeat many times because one time only one element sorted. The same work you have to do in the loop. So due to that, this is the top loop written for do multiple pass, and this is the first loop just pass first pass. Okay, let's write the code and you can easily understand. Okay, so here let's a simple. We have a one list. Okay, my list. Yeah. And here we have a some same element let take. Okay, so that you can easily understand. 535382 5382 4. Okay, 842. Okay, 842. Okay, this is a simple element. Okay. So here we are going to write the approach. So let's simple step by step. This is the first time I'm going to explain very simplest way, and later part we can add directly. Let's understand. The first thing we have to what we have to do. What so okay. So first time what happened? So now take pen. And here let's first steps we have to this number like here same let's see same number. 0, 1, 2, 3. Okay, so this is the 0 position, 1 position, 2 position, 3 position, 4 position. Okay, yeah, this is the 0, this is the 1, this is the 2, this is the 3, this is the 4. First, you have to make a compare between these two. Okay, these two. You compare 0 and 1 element. Compare 0 and 1 element, you find swapping required, you can say yes, swapping required. Then you can say swap the number. So you can say swap the number 3 and 5. So this is the first two. And then you're going to compare 1 and 2. Then 2 and 3. Then 3 and 4. And after that, you are not going to the compare. So why? Because this is the way, whenever you go this line, you notice the last element will receive. Okay. So let's write the only one passcode first. So here I'm going to write. So let's simple say define bubble sort. Okay, and this will return your list array list. You can say. Okay. Okay. So we are going to the very simple. First, we to know what is the my input list. So you can say, hey, this is my length, number of element. So length, number of element. Okay. So it's count till now clear. Whenever I can pause, they print. Let's and so first things we have to run loop from here to here. Okay, so you can say, hey, let's run a loop, for loop, 1 2 range. Okay, 1 2 range, and here we have to compare first and second element. Okay, so I'm not going to first simply well letter part we write the, let's start from the J, J from start to J, and let us start to N, and here say check if first element, this is the element 0 element, and next element 0 plus 1. You can say J plus 1. This is the first element 0, this is the 1. I want to compare two. So this is the first element is greater than this. If greater than, if first element is greater than second element, this is the 0, if this is start from the 0, this is the 1. So if greater than, then we have to swap them. And for swapping, what we do? For swapping, simply say, hey, whatever the value of this place, we have to change this. So you can say a of j place, change the value array, array. Okay, so what you do, you change the value this, and notice here, be clear, this code is very simplified, but let's understand. If we have a two number, this is the 0 place, this is the 1 place, here our j. Okay, j equal to 0, and this is the j plus 1. Here say a of j, a of j means 0 position, here 0, here j plus 1 means 1 position. This is referring to this position, and this referring to this position, right? Here say ki a of j equal to j plus 1. That means you, here previously what is the value, 5 and 3, here previously 5, and here 3. You say at the 0 position, at the 0 position, you put the value of j plus. Here j plus 1 means this value are putting the 3 here. So this is the one line, okay? But you also need to do, at this place we have to put this value as well as, right? So, Python have a very concise way to make the swap. In other programming language, if we have write the multiple steps, okay. If you notice, if you copy this to here, your 5 value will be lost, because 0 place initially 5. You replace the 3, then where is the 5 value? So previously in the other language, we hold one temporary space. First, this what is the value of this? We store here. This is the temporary value 5, and then we place the value here 3. Okay, and whatever the temporary value you can go to place here. So in other programming language, we have to take one temporary variable here. Say hey, and because if you copy here, you too lost this value. So let's clear it. So here you have to take one temporary variable first before copy here. Take a temporary variable and store this value first, whatever the value 0 is right now. And now 0% value put, and again say at this position, whatever the j plus 1 equal to new. So click here. If this is the simplest way to sorting the swapping the element. So again repeat. This is the first, you take the temporary value here. You were two places. Initially, this was the 5 and this was the 3. So what I did first, I hold one another variable and copy this value in the 5 here. Okay, 5 here. Again, say key at this 0 position, you copy the value of j1. This is the value copy. Now it's become a 3. Okay, now again copy the whatever the temporary value at this place. So now we copy here, this place. So this is the way we are the swapping two element with the third variable. But in a Python, this 3 line of code concise in just 1 line of code. Internally Python do, but we understand if swapping up two element within an array, we can use this the temporary concept. But here Python, instead of that, Python simply say, no, I'm not going to write this way code. This also work. Swap. So A of J array of J. So here simply say कि first position type this and this position write this way. So this is the sort the same approach what here simply you write in one line arrival. So this is done and this is the loop done and this is the done. So this is the one passive come. So let's test. Hey, uh, print my list. The first we have to print my list, and after that again sort my function and again print this. What is saying? Something wrong. A array greater than J plus J. This is J plus. Okay. Line number 15. Okay. This print. With the fault, this is my list. This is sorting length. Just start from shape to length. Your array length. This greater than this. Shape name. This simply we have to complete. What is the problem here? So okay, index out of bound range. Here say notice. So we have to sometime whenever you are understanding this means notice here our index index. Okay, so here this is the 0, this is the 1, this is the 2, this is the 3, this is the 4. Okay, so first time you are going to comparing 0 and 1, right? It's so nice. Whenever your this is the J0, that means whenever you are comparing this 0, you are comparing 0 and 1. Okay, J and J plus 1, right? Now when you are going 1 1, that you are comparing 1 and 2. When you are going to the 2 place, you are comparing 2 and 3. Whenever you are going to the third place, you are comparing third and fourth. Whenever you are going to fourth place, you are comparing fourth and the number which not exist. So whenever you run this loop always go to the minus one because you are going to the comparing the next element. So whenever I are the second last, you don't need to compare here. So here you can just click clean and just say here just whatever the number minus one. So that you can say because we are getting. So notice whenever you run and notice the first time your pass your list is this first element is the just say this is the original input input. So this is my input and notice first time 3 5 4 2 8 8 become the last place right now. So but in this case you have just run one loop and get the one value go to the right place. So this is the pass one. So this thing we have to repeat until for next pass. So what you do, you are going to write this complete code in another loop as well. Here you can say you can going to write another loop for I and range. So what you are going to do here, you are going to make this as a in a loop. So now here you say this is the code I want to inside a loop. Okay, this is the code I want to in a loop. So this is from 0 to the number of elements. Okay, so notice here instead of going to the n, I am going to the zero element. Here n is the length and minus 1 again. In this way, notice here our always n is the fix. N is the your number of element 1, 2, 3, 4. Again, understand here. Here our first time comparing this, second this, third this, and fourth this. Okay, after that, the first time one is the fix, lowest place is the 8 is the fix. The next time we have to run loop again minus 1 here. Next time again minus 1. The number of times here I going to also we have to minus, so that next time don't compare this. Next time don't compare this, because second pass, second element come here. Okay, so let's clean. If you notice here, if you just control Z, okay. If you what happen, I write the same code again. Again, let's just for simplicity, I write the same code again. Okay, the first time this is the one, second pass this is the two. But you have to, if you run, they are going to two elements are the. Let's print after this. We have to call the just this function. Let's call inside the here. Okay, yeah, here. In the so note what happened. This come here, go and print. And you can just call here sort input. So notice this is the first time, and let's write here again this. This is a pass one, and this is your comma pass two. So notice pass one, this is 8, and pass two, this is no. So notice here still we are comparing till minus 1. So here instead of minus 1, we have to again compare minus 2 times, because the first element we have to already first pass, one is already sorted. The next type again I'm going to by comparing this as well as, so you can say again a minus 1 as well as, that means minus 2 times. Still it's a work fine. Okay, similarly you can go for pass 3, pass 4, pass 1. Okay, okay. Similarly now here you can say pass 3. With the pass 3. So in this way, first element greatest, second element greatest, third element. Each times you have to do this the minus 1, minus 2. Instead of this, why not I copy paste code this one time, two time, three time. So instead of that, we are go say, hey, this code go inside the loop. So instead of writing all this, we are going to write this code in the another top loop. You can say, hey, for range, okay, and here instead of always this, again say minus I as well as. Here first time I 0 minus 0, Second time you can say -1, -1, -2, -2, -3, -3 in this way. So this is code become a loop. Okay. So now this loop is run this code in the first time. This is the I0, 0, -0. This is the 1, that's -1. This is that means -2. This is again 3, 2, 1 -2, then 3. So in this way, you can say just -1, -2, -3. You are reducing the output. And if you run, now your complete pass. So let's write this code inside a one pass. This is the loop. I want to once this pass come, just print it. Pass, let's keep pass, comma, I. Okay, pass 0, you will just say this. So notice this is the pass 0, 8, second pass 5, third pass 4, second pass 3, and now comparing happen. So in this way, notice 1 time, 2 time, 3 time, 4 time, 5 time. We are comparing 5 pass. So here we can think about the optimization. Really, once notice here is also our list is sorted. Again, our loop go and again doing the sorting again. So if there is a notice here, swiping first time, yes, swiping happen here, right? Second time again swiping happen here, right? The swiping happen here. Five move to the here, right? Now, third time again swiping happen, 4 move to here. Third time swiping happen here. But after here, notice in those two, no swiping happen. Still our code going to the run. So for that, there is a concept about the optimize. So instead of you writing uh, always to the loop, first time always check, is there any swapping happen or not? If no swapping, that means your list is already sorted. Why you go loop again and again? So for those scenarios, we have to concept to break the loop. Instead of here, this loop run from 0, 1, 2, 3, and the 4. Always first time, second time, third time, fourth time, fifth time. So always they are running. I can break this loop if there is no swapping happen. Yes, that is known as your algorithm optimize. So always things first you define your step and whatever the comparison happened, once you solve the problem, then you think I can optimize my algorithm or not. Okay, so we have to put our optimization here. Yeah, in this way our code works fine, there is no problem, it's a solving problem. Okay, and here just input and here just output. Okay, now notice our this is the input, this is my input, and this is my sorted output. It's fine. But our loop going to the past 5 times. Unnecessary this loop is going. So we can avoid. How to avoid? Just make one flag. Hey, this loop required or not. Let's one flag f equal to just make a what say swap is swap or not. Take a variable same as a here mention like a swap true or false. Okay. So here mention hey is swapped or you can say sorted is sorted. How to decide if there is no swapping happen? If here go, you can say is sorted true. If anything happen, any swapping happen, that is become a true. That means pass this loop is still going. Okay. And if there is no swapping happen, after that I have to say, hey, I do not need to go further. Okay. So here you can say check condition. If is sorted, then we have to use the keyword here. This is a concept of the break. You can say just break the loop. So now this top loop is going to break if this is a not sort. Until sorted is true. If not true, then continue, and you can run here. Now you are taking just here. Okay, notice we are getting the sorted element just in the 0, 1, 2, 3 pass. Pass 4 is not required. Okay, because here we break the loop and the particular again we are not going to. So this is known as optimizer. Here is just starting each loop. Whenever I am going to start this top loop, this is the top loop. I am just checking is a variable. This is a false. Okay, false. And I am going to, this is the inner loop. This is the inner loop going to check till here, checking any swapping required or not required. If any swapping required, it become a true. This means it's still not sorted. Not sorted means if it's not sorted, then it is not true. If not true, then it still continue. It still continue. When yeah, they are making a your true. Whenever swapping, yes, it's become a true. So here say true. This condition is not met. Then again going to the next URL next times. So in this way, this sorted and breaking just for your optimization. You want to your system code should be optimized, less memory, performant. For those scenario, we are adding such code here. This code. Okay, this is not a part of your algorithm, but your algorithm should be optimized. They respond quickly, they take less memory. So due to that, we are writing unnecessary. Don't consume your CPU time to run your code. That's not required. So this is the way you can optimize your algorithm. If you just comment out this, run, you notice run, it is the always only 3 times and get the sorted list. If we are not apply this line of code, if you not apply this sorting algorithms like here, 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 okay, and if you notice they are do sorting, but required one more extra comparison. So hope this makes sense. Your optimize, okay. So always whenever you're writing algorithm, think is any comparison, any loop, any extra things we can avoid. Let's do that is the optimization part. So this is the way we can implement. This is our final code. Generally, this is not required. You can also just remove this. Okay, this is just for your sake printing. So this is your final code. This is just your final code for your bubble sort that is optimized. And notice this is my input and this is my sorted output. So hope this the way you are writing algorithm is step by step. Look here, steps one, pass one we did, pass two did. Then notice why I am to copy the same code again and again. Let's do the another route. So the same. This is my original logic. I do again pass one, pass two, pass three here. So this is the way you can write sometime over two loop. There is a reason why we are going to two loop or three loop or four loop, because our algorithm say we have to repeat until the list is not sorted. So this is the your code, same code I written here. Whatever the written here also, we have just this is your uh, inner code. This is the your this is the inside loop. This is the inside. Okay. So here whatever the same thing written, I also have true, and we have just. Okay. So hope this will make sense or make you can say way how you can write the algorithm. Writing algorithm is very simple. Just write step by step works, step by steps work. And if you required some phrases, loop, let's make a loop. Sometime you required something, a break, just use the break. Break means you are going to the outside of the loop. Don't want to repeat this code again. So in the writing algorithm, your loop generally used. your if and else when you less than, greater than, equal to, this conditions used, and sometime you require the your break used to breaking the loop. You are going to outside of the loop. So these are the small tools: looping, condition, breaking, continue. These are the steps, small by small steps you perform, and finally you build one complex algorithms or logic that serve your customer a specific problem. So whenever you are going to write any algorithm, first you try to define your steps and then implement step by steps. And later part you think here you required any loop, required any condition check, required any kind of optimization. Let's do. So this is the way you can start learning to write algorithm. So might be this is the very simplest way, but let's start practicing to implementation of such algorithm. That if you write such code, it will help you. You feel comfortable. You will feel get some confidence. Hey, now I am able to write some algorithm. So whenever you write small algorithms, this build your confidence high level, and after that you can start working in a project, working with any kind of use cases. You can very easily feel comfortable to use this defining a method, using the loop, using the if block. Maybe require some break, something for optimizations. All the things you be comfortably going to use them. So let's start practicing to write your own algorithms. So that is for the today. Thank you.